Now let's talk about how to generate random matrix of integers in NumPy. For example, suppose that I want to generate a 3 by 3 matrix like this, which all of its elements are random numbers between, let's say, 1 to 6, for example. In order to do so, I simply type np, which is the alias name for the NumPy package. Then I want to use the random module, the random section of this NumPy package. So I want to use the random module of the NumPy package. And then it has different functions. And one of those functions is the randint function, which generates random integer numbers. So I want to generate random integer numbers between 1 to 6. So the lower bound is 1 and the upper bound should be 6. But remember, you should write 7, not 6. Why? Because this value is exclusive, not inclusive. Then you should pass another argument called size. And for example, here you want a 3 by 3 matrix. So you should pass size equals to 3 by 3. And for example, you store all the results in a variable, let's say called x. And if you print the x variable, and if you run the code, you can see here is the result. And remember, whenever you run the code again, you will get different results. It is possible to get different results. So as you can see, it is going to change every time I run the code. Now suppose that I want to generate 3 random integer numbers between 1 to 6, not necessarily a matrix of random integer numbers. In order to do so, suppose that I want to generate 3 random numbers, so I should pass size equals to 3. It means generate 3 random numbers between 1 to 6. And also, you can write it this way as well. So you can write it this way as well. So if I run a code, you can see here is the result. Now let's talk about how to generate a random number between 0 and 1 in Python NumPy. In order to do so, that's very simple. We can simply type np.random. It means from the NumPy package, from the random section of this NumPy package, I want to use a function which is called random, which is used for generating random number between 0 and 1. And I can pass an argument called size. For example, suppose that I want to generate a 3 by 3 matrix, which all of the elements are random number between 0 and 1. So I should pass size equals to 3 by 3, and then I store the results in a variable, let's say called x. And if I print the x variable, you can see here we have a 3 by 3 matrix, which all of the elements are random number between 0 and 1. And if I run the code again, you can see whenever I run the code again, it is possible to get different results because it is totally random. Now let's talk about how to generate a random array of floats between a range of numbers. For example, suppose that I want to generate a 3 by 3 matrix, which all of the elements are random float numbers between 2 and 5, for example. In order to do so, I simply type np.random, and I simply use the uniform function, and I should pass 2 and 5, which is the lower bound and the upper bound, and I should pass another argument, which is the size of our matrix, of our array. So for example, suppose that I want a 3 by 3 matrix. After that, I store the results in a variable, let's say called x, and if I print the x variable, and if I run a code, you can see here is the result. But now you may ask, how can I generate random array of floats between a range of number with limited decimal digits? For example, 2 decimal places in Python NumPy. In order to do so, first let's cut this, and I simply type np.round because I want to round all this stuff to 2 decimal places. And the stuff that we want to round is the thing that I have cut. So this is our matrix, and we are going to round that matrix up to 2 decimal places. That's it. And now I'm storing that in a variable called x, and I'm printing the x variable. So if I run a code, you can see now we have generated random array of floats between a range of numbers, let's say 2 and 5, with limited decimal digits. And now let's suppose that I want to generate random numbers from normal distribution in Python using the NumPy package. Suppose that I want to generate random numbers from a normal distribution with mean equals to 1000 and a standard deviation equals to 5. That's very simple. In order to do that, we simply type np.random. It means from the NumPy package, I want to use the random section of that NumPy package, and from that section it has different functions, and one of those functions is the normal function. So first of all, I should pass the location, which means the mean of our normal distribution. So the location is our mean, so I should pass 1000. And the scale parameter, which is the standard deviation of the normal distribution, is 5 in this example. And also, for example, suppose that I want to generate a 3 by 3 matrix from normal distribution. I want to generate a 3 by 3 matrix which all of the elements are random numbers from normal distribution. So I should pass size equals to 3 by 3. And then I store the result in a variable, let's say called x. And now if I print the x variable and if I run the code, you can see here we have a 3 by 3 matrix which all of the elements are from normal distribution. So if I run the code again, because it's totally random, it is possible to get different results. Now let's talk about the shuffle function. And what do I mean by shuffle? As you know, the meaning of shuffle is rearranging in random order, reordering in random order. So suppose that I have an array which is called x and it contains a couple of numbers, 1 all the way up to 5, and I want to shuffle, rearrange in random order this array. In order to do so, I simply type NumPy.Random. It means from the NumPy package, from the random section of that NumPy package, I want to shuffle, use the shuffle function in order to shuffle x. And after that, I should print the x variable. So if I run the code, you can see now we have shuffled our array. So because it's totally random, if I run the code again and again, it is possible to get different results. And you should remember a very important note, and that note is the shuffle function does all the stuff, does rearranging in random order, quote unquote, in place. So when I say it does all the stuff in place, it means this shuffle function doesn't return anything. And because it doesn't return anything, if you store the results of this line in a variable, let's say called y, and if you print y, you will get none. So you can see if I run a code, I get none. Why? Because the shuffle does all the stuff, quote unquote, in place, and it doesn't return anything. But now let's talk about the permutation function in NumPy Python. The permutation function is very similar to the shuffle function, but as you know, the shuffle do all the stuff in place, but the permutation is not going to do all the stuff in place. It is going to return something. So if I want to use the permutation function, so I want to permute this array which is called x, and remember that this function does not all the stuff in place. It is going to return something, and I want to store the output of this function in a variable, let's say called y. And now if I print the y variable and if I run the code, you can see here is the result, and because it's random, if I run the code again and again, it is possible to get different results in every one. And also there is another interesting thing about the permutation function which I want to talk about, and that thing is if you pass a number, for example let's say 4, then the permutation function is going to permute the range of 4. So let's run the code, and after that I'm going to explain the output. So you can see here's the output, and if I run the code again and again, it is possible to get different results. As you can see, it is going to permute the range of 4. So when I pass a number to the permutation function, it is equivalent to passing range of that number. It is equivalent, for example, in this case, in this example, it is equivalent to passing range of 4. And as you know, range of 4 is 0, 1, 2, and 3. So when you pass 4, it is going to shuffle these numbers, 0, 1, 2, 3, which you can see here. So passing a number to permutation function is equivalent to passing range of that number to permutation function. That's it. So now let's talk about the NumPy choice function. So as you can see, I have defined a variable called x, which is an array of a couple of numbers, 1, 2, 3, 4, 5. And let's suppose that I want to choose one number randomly from this x variable. In order to do so, that's very simple. I simply type np.random. It means from the NumPy package, I want to use the random section of that NumPy package. And then I'm going to use the choice function because you want to choose something from x. So first of all, we should pass our array, which you want to choose something from. So I want to pass x because I want to choose something from our x variable. Then we should pass the size. It means how many values do you want to choose from x. So for now, suppose that we want to choose one number from x. So that's it. And now if I store the results in a variable, let's say called y, and if I print y, you can see here's the output, which is 4. And if I run the code again and again, it is possible to get different results in every one. Now suppose that you want to choose more than one number from the x variable. In order to do so, you can pass different numbers to the size argument. For example, if you pass 4 and if you run a code, you can see here is the output. But as you can see, it is possible to get repetitions. So you can see we have 2 5s and 2 1s. So maybe you ask, how can I do all this stuff without any repetition? And remember, this is technically called sampling with replacement. And when I say sampling with replacement, means it is possible to get repetitions. But if you don't want to get repetitions, that's very easy. You can pass another argument called replace. So you should pass replace equals to false. It means you don't want to sample with replacement. So if you run the code again, you can see here is the result and you don't see any repetitions. And if you run the code and again, it is possible to get different results. But remember that you're not going to encounter with any repetitions because replace is equal to false. Now I really suggest you to watch this video, which is on the screen now.